Good morning, students. This lecture, I'm going to explain about how to implement binary search tree. So what is the binary search tree? Binary search tree is a binary tree and has some constraints. That means the values of the left side should be less than the root node and the values of the right side should be greater than or equal to the root node. Okay. So how to implement the concept with the help of C language? So it is the binary search tree. Okay. So first of all, I'm going to declare the header files. Include stdio.h, include stdlib.h. Then the structure concept. It is a linked list implementation. So we need a node. So the node should have three parts. One is data part, that is integer, and the remaining two parts are address. One is left child value, another one is right child value. So we need to declare it as a self-referential structure. So struct bst left, then struct bst right. Okay. Then void main. Here I'm going to use two functions. One is create function, another one is in order. With the help of create function, I can able to create number of nodes. With the help of in order function, I can display what I have created, right? So the create function, here I'm going to pass two arguments. One is the node and another one is the data. Node means it is a structure type. So struct bst asterisk comma one node I'm going to pass, it is an integer value, okay, one value. And the return type of this create is, the create function is going to return one node. So it is also struct. Node means what? It's a struct type. So bst asterisk, right? And one more function I'm going to use, it is in order. The return type is void and in order of the node. What are the node I have created, that only I can pass. So struct bst only I can pass. That means one node I can pass. Then add the object for this. Struct bst asterisk root, and initially the root value is equal to 0. Then two more variables I'm going to use. One is x comma n, and the number of nodes I'm going to declare. So that's why I have given the printf enter the number of nodes. Okay. Then scanf, based on the n value, I'm going to create number of nodes. So I have read the value for n. Then printf enter the value of the node, right? So scanf %t address x, right? Yeah. Then I'm calling the function, it is a create, the node, the structure object root, and the x value I passed. Okay, and it is stored to the root itself. root equal to. Okay, then this function I'm going to call. I call the function. Then one more function. It is what? In order. Here, that root only I can pass. Okay, and based on the number of nodes, I use the for loop. How many times the create function is going to execute? So integer I is equal to 1 to I less than n, I plus plus. Okay, here this values should be executed based on this for loop. Okay, n based on the n value, the number of nodes going to inserted. Going to insert, then that node is passed as argument for the in order. With the help of in order, you can able to display the nodes. Okay, what are the nodes we have created? Okay, so we called the function. So now I'm going to define. Okay, so how to define the function? The create, right? So what is the return type of the create? The structure type. So I'm defining that struct. So use it is struct bst asterisk function name is create. What are the arguments we need to pass? One is object bst asterisk head and integer x. Two values I passed. Okay, these two values we can get from the main function itself. Okay, so now I'm going to check what is the head. If initially the head is null, right? And check the condition. If head equal to null, what happen? Head is equal to null means what we have to do? We need to create, we have to insert one node, right? So then only the head value filled. So head equal to null, I'm going to assign the node for the head with help of one new function. That new function name is new node. Here, I pass the value x. Okay, so this new function we need to declare here. We need to tell the compiler that is what is the function name? Function name is new node and integer type. What is the return type? It should be return one node. So it is a structure type. So struct what bst asterisk. Okay, then we can call. So head is equal to new node. So we need to define the new node function, right? So I'm defining here. So struct bst asterisk new node integer x, right? Here, create one object for allocate the memory for that, okay? So that is the struct bst asterisk. I'll give the object as new one and allocate the memory for this new one equal to struct bst asterisk malloc size of struct bst, right? So we are allocating the memory for that. Then new one tends to data equal to that x and new one tends to left equal to null. Initially it's a null and new one tends to right equal to null. One node is created, right? Data part is filled, left child filled, right child initially. Then I can return new one, right? So now this values assigned here. It is returned to here. Okay, this new one node is assigned to head. Okay, When I'm going to insert the next node, I'm calling the same function, right? So first I is equal to 1 means we read the x value and the head is created. When I is equal to 2, I'm calling the create function again. What happened? I'm checking the head value. Now the head is not equal to null. Okay. So if head is not equal to null means you can go to else part. Under the else part, what we have to check if head is not equal to null. Under the else part, we can check the value, right? If what the value I'm going to insert, that x is less than this head tends to data. If it is less than means you can assign or you can keep that value in the left child. So head tends to left equal to, I'm calling the create function recursively now. Okay, whenever the x value is less than of your head tends to data, that value should be keep in that left child. Okay, so that's why I'm calling the create function here. What is the node I can assign? It is the head tends to left, comma, the x. Else, that means if the x value is greater than or equal to the head tends to data, then head tends to right equal to create, head tends to right, comma, x. Okay. Then we have to return head. Okay. So head is equal to new node. Only one node means also you can return it. Return head. Okay. So now this part is over. Next, we can call the in-order function, that is void in-order struct bst asterisk head. I'm checking if uh, head equal to null means it does not return anything. Return nothing. Else, in order of head tends to left. That means left you can search. Then printf the value x in order it tends to right. That's it. Okay. So head equal to null means nothing. Otherwise, first left child, then value, root value, and the right child. Okay. So let me execute that program. Everything we declared, right? X and N. Is there anything we can check? Okay. So run. Yeah. Here semicolon is missing. 40th line. X is undeclared. 63. Yeah, here how do you want to? Head tends to data. Right. And the number of nodes, 4 nodes. The value of the node, 10, 3, 12 is 3, 10, 12. So here you can give the tab, then we can see again. Enter the number of nodes is 5. Enter the value of the node 10, 2, 7, 16, 2, 7, 10, 16. So the less than value is kept in the left child and the greater than value kept in the right child. Okay, I hope you understood the concept of binary search tree. Thank you, students.